you should wear it anyway.
Yes.
I'm recording.
Wear it and own it.
Yep.
But anyway, I've already talked to people here in Keysville about Friday's trip. So y'all people in Alberta, if you have not emailed Dixie about the lab Friday, please give us an answer today, because they're going to be providing food and they need to know how many meals to do.
Can I count for 2? I like food.
We'll see. Well, a couple people may not eat their full share. So what about the rest of you? Flint, Carolyn, are y'all going?
I think I'll be going.
Okay. Kaylin, what about you?
Yeah, I'm emailing her now.
Excellent. Alex?
No. Alex says no.
Yeah, he's scared.
Alex is very scared. Well, he's still in the room with me. What do you expect?
Exactly. I'm 50 miles away and I'm still scared. Oh, well, Longan, shut up, let y'all have class, and I gotta go. You love it.
Guys, good luck.
Right, have fun.
You're wearing stripes because you don't want to be spotted. I know, sun drop.
Nice.
It's your butt in this classroom.
Anyway, bye, y'all. Have fun. Oh, wait, good morning, Leanne.
Oh, yep, good morning.
Oh, and good morning.
All right. Well, I'm going to wait. We've got, according to my clock, we've got, about 2 more minutes. So I'll wait just to see if anyone else. It looks like Patrick Henry's kind of empty right now. So see if anybody else.
Another one. We got another one. Why do y'all always sit out of the range of camera?
I used to. I don't like being on.
Yeah, there are some of y'all that I don't think I've ever been able to see on camera because it kind of focuses, Flint is right in the middle of it.
Yeah, Flint. Go, Flint.
Yay.
Normally I'm in front of Flint, but I'm behind here, pretending to be Tom.
You're doing a good job. You just need to come up with some corny jokes to write on the board, and then you'll be good.
Oh, I can do that all day long.
Don't encourage her.
Oh, look, I have a whiteboard right behind me with markers. Yay! Yes.
Patrick Henry looks pretty empty today.
Yeah, Tyler wasn't there, and I don't think he's going to be there, so we have, there's one person at least, though.
Oh, there's another person.
Another person. Woohoo, let's count the people. Sorry. People. Oh! How do you count cows?
Huh?
How do you count cows?
I don't know. I haven't heard that one.
With a calculator.
Ah, I like it.
Flint said my jokes are bad, but I'm dressed up as a bat, so I said no, they're bat.
Yep.
I'm really hitting it out of the park today. I put a spun on that one, didn't I? It came back too fast. Too bad you didn't catch it. Right, Flint? Now this is a whole nother kind of bat. I could go all day long.
All right. Well, did you have a question or something? Caitlin, if you want to go ahead and hit record, since it's 10:30, I'll go ahead and get started.
It's recording.
You're recording already. Okay, awesome.
Yep.
Okay, so just a couple of announcements before we get started. Like Tom just said, please reply to Dixie's email. She really needs to know how many people are coming. So another announcement, if you looked at the syllabus, some of you probably already saw this announcement, but it says that your test is going to be this Thursday. But obviously we're not done with the material yet. So because we missed those 2 class periods, your test is going to be moved to next Tuesday. So November 14th. So today we're going to finish up the last 2 lectures in section 3, and they're really short. There's not a whole lot of information in each one. And then Thursday we'll do a review in class, and then the test will be on Tuesday the 14th. I also posted an assignment for you to do that is going to also act as your study guide for section 3. So it's quite a few questions, but it is an assignment. It's worth 10 points. And the reason that I did that instead of just making it optional is that I really, really want you to look at those questions and answer them and go through your notes and get familiar with that material, because it is hard and it's a lot of stuff. So that will be due next week. So that's already posted on Blackboard. So go ahead and do that so that you can be studying. And I will try my best to grade those kind of as you do them. So if you want to get that assignment done early to get feedback on your answers, you can go ahead and do that, and I will try to grade them as quickly as I can as they come in. So does anybody have any questions about the test or the assignment or anything?
Do you know how long it's going to be?
How long the test is going to be?
Yeah.
It'll be about the same length as the other one, so probably around 50-ish questions.
Okay.
So the assignment is like I think I stopped at like 40 questions. Because so there will be a few things that are in the notes that I'll go through on Thursday. Obviously, the questions don't cover every single little thing, but they're a really good starting point if you do those. So it'll be somewhere around like 50 questions probably.
Okay. Cool.
All right. Well, with that, we will go ahead and get started today with growth and development.
Oh, baby goats. Yeah, those look more like goats than sheep, right? They're cute.
Actually, those might be sheep. I think they're sheep. But it's kind of hard to tell.
Kind of hard to tell. They're cute.
Yeah, they are really cute. I had to really resist just having YouTube videos of baby goats playing like every day to start. I love watching that. So today we're going to be talking about animal growth and development. This is not a super long lecture, and some of the terms in the lecture you've already heard by now from other class periods. So we're just going to I'm going to explain how it all kind of fits together. So growth is a combination of a lot of biological processes that will lead to a mature animal. So obviously it's really important to production of livestock as well as performance of horses. And any other species that you need, performance from or products from. So the cellular basis of growth encompasses two distinct processes. So there are two ways that cells can grow. So you have what's called hyperplasia, which is an increase in cell number, and then hypertrophy, which is an increase in cell size. And so, again, I'm weird with like the way that I remember things, but the way that my biology teacher explained it to me in high school was that hypertrophy is like a trophy. So you want a bigger trophy, like for anything that you do. So trophy is like size. I don't know if that helps any of you remember it at all, but it always worked for me. I think trophy, big, increase in cell size. And then hyperplasia is increase in number. So it's the other one. So not sure if that helps you, but it's always helped me remember. So
I remember. Hey.
So this picture on the right just kind of shows you, so if you have your 4 cells, hypertrophy, you have the same number of cells. The cells are just getting larger. And then with hyperplasia, you can see that some of the cells have divided. And now you have 6 cells instead of 4. So you have an increase in that cell number.
That makes sense.
So growth can be measured in many different ways, and that varies with species. So, for example, in humans, we typically measure height. So you might also measure weight for kids as well to make sure that they're kind of growing properly. For animals, it's different. For horses, we measure height at the withers, like we talked about. So how you measure growth kind of depends on the species that you're looking at.
Mm-hmm.
So these are what we call kind of crude measures. So that crude measures basically just measure overall growth. So they're just kind of telling you the size of the animal and how it's growing, but it's not telling you anything about individual organs or muscle versus fat. It's just an overall measurement of their body growth. So growth in livestock, poultry, aquaculture, and cats, dogs is typically measured by an increase in body weight or average daily gain. So how much are they gaining every day? So typically, like in my research trials, we measure growth performance as average daily gain and average daily feed intake, and then their feed efficiency. So how well are they doing on that feed? But so average daily gain is a really good indicator of how well they're growing and how much they're actually gaining every day. And you can calculate that just by weighing them and dividing by the number of days. So it's a pretty easy measurement, and it gives you a lot of information. So there are some techniques that will provide more specific information on growth, because remember, like if you're just getting average daily gain or body weight, it doesn't tell you much about what's actually going on in the body. So there's serial carcass analysis. You can use isotopes, just which you would kind of give in the feed, that are kind of just labeled compounds, and that can help you measure the rate of synthesis of protein or fat. So that could give you an idea of how much, whether they're synthesizing more protein or more fat. There's also non-invasive methods like ultrasound, magnetic like MRI, that can determine the composition of a live animal. So I actually did this during my master's with something called a DEXA scan. It's kind of basically like an X-ray type deal. So we could actually see on the screen, like inside of the animal, and get the percentage of bone, the percentage of muscle, and the percentage of fat. So we could really get a good idea of how the diets that we were feeding were impacting their composition. Of course, all of those are really expensive. So typically, if you're just a producer, you're going to probably just be measuring your average daily gain or height if you have horses. Nitrogen retention is another way you could measure growth, and then a back fat probe, which can be used in different livestock species like cattle and pigs. Sometimes it's typically used. So different methods, just depending on how much money you have to throw around and how curious you are at how well your animals are growing. So growth can kind of be drawn out with different growth curves. So the typical growth curve that shows the growth of an animal from conception to maturity is called a sigmoidal curve, or S curve. And you can kind of see why. It kind of looks like an S shape. So S curve, kind of easy to keep straight there. So basically, this S curve will depict the growth of an animal throughout its lifetime. So if you look, this one's actually from your book. You have conception, where it's kind of growing, obviously there's development of the fetus. And then right here where age starts is where that animal's going to be born. So it's going to be like a day old. And so then you have rapid growth after it's born. And then eventually you'll kind of get to this point where they reach maturity and they'll start leveling off. So if you kind of extended this graph, this line would kind of just go off horizontally to the side, because once they reach maturity, they're not going to continue to grow anymore. So this is just a good way to kind of visualize how animals typically grow. So as far as the growth of organs, so they don't all, they kind of happen a little bit of overlap, but there's kind of an order to how the organs will actually grow. So bone actually starts first. So the skeleton and everything will be laid down, assembled, and then that's followed by muscle, and then adipose tissue is going to be third, which kind of makes sense because typically even in a growing animal, they're going to lay down muscle, and then any extra nutrients are going to kind of go towards fat. So it kind of makes sense that fat, adipose tissue would be third. And then bone first obviously makes sense because you need the bone to lay the muscle down onto and to keep the structure of the body in place. So there are a few hormones that control growth. So we're only going to talk about the kind of the main one, or there's kind of two that we'll kind of mention. So the principal hormone that controls growth is growth hormone, which I actually really like because this is one of those hormones that its name actually like tells you what it does. A lot of hormones have weird names and you have to kind of remember them. Somatotropin is also another name for growth hormone, but that's kind of one that really only like biologists or chemists will kind of use. But growth hormone is fine for this class, and that's what most people typically use. So it's a protein hormone that's released from the anterior pituitary gland, so in the brain, and it's under the control of releasing factors from the hypothalamus. So growth hormone is regulated by a couple of different things, and for the purpose of this class, we won't really go into how it's regulated and everything, because I think that's kind of getting a little deeper than you need right now. But just know that it is regulated in several different ways from signals from other parts of the brain. So growth hormone stimulates the growth of bone and muscle indirectly by enhancing production of insulin-like growth factor 1 from the liver. So growth hormone is the principal hormone that controls growth. However, it doesn't always control growth directly by itself. So it will actually cause another hormone, this IGF-1, to be produced, and that will stimulate the growth of bone and muscle. And so IGF-1 levels of that hormone can actually kind of go back and monitor the levels of growth hormone. So for example, if you have a lot of IGF, then you don't really need to keep producing growth hormone because that signal has already gotten through. So it may do a feedback and kind of stop the production of growth hormone, just as kind of a general example. But so that's basically how it works. Growth hormone kind of works through this IGF-1 to impact growth. So growth can be divided into two main phases. So prenatal and postnatal. So they're kind of pretty much exactly what they sound like. So prenatal is growth that occurs before birth. And then postnatal is growth that occurs after birth. So during the prenatal period, you're going to have cell differentiation, which means that those cells, those stem cells that were undifferentiated, are going to start becoming adipose cells or sex cells or whatever they're going to be, whatever organ they're going to be. And then they're going to start dividing to make sure that that organ is growing properly. So then in postnatal growth, that mostly occurs due to hypertrophy. So that's going to be where those cells that have differentiated and divided during the prenatal period are going to start getting larger so that the animal can grow. Of course, you will have some cell division like we talked about, like in the gut, the cells that line the intestines, because they kind of deal with a lot of nutrients and pathogens and things. So those cells turn over. So you will have hyperplasia of some cells in the body, but typically in the postnatal period, it's hypertrophy. So sexual dimorphism is something else that happens with growth and development. So sexual dimorphism is just when a characteristic of an animal that's unrelated to reproduction shows differences between males and females. So, for example, there could be a large difference in the growth rate of a species or breed within a species, and that could depend on whether it's male or female. So on average, males typically grow faster than females and will achieve a large mature body size. So that's something that is not really related to reproduction. You know, it's not looking at what parts they have, but that's another factor that will kind of distinguish between the two genders. So the main factor behind that is testosterone, which we talked about in the last class. That's the major male hormone. So testosterone will actually kind of cause the males to grow faster, and obviously they'll end up with a larger mature body size. This is reversed in some species. So for some reptiles, the female will actually be larger and grow better than the male. So it really does kind of depend on the species. In general, with livestock species, the male is going to grow faster, but there are some exotic species out there where that's the opposite. So obviously nutrition and growth is extremely important. So we've talked about nutrition before and how important it is to meet the requirements of the animal. So maximum growth rate requires optimum nutrition, and I cannot stress that enough. So like if you're not meeting an animal's requirements, their growth is going to be halted, slowed, it may even stop, and it's going to really impact your production system if you have animals that are not reaching their full potential just because of a mistake in your formulation. So nutrition is extremely important because you can have the best genetics out there, but if you're not feeding those animals to meet their requirements, they're not going to grow properly. So there is something called compensatory growth or kind of catch-up growth. So I tend to think of compensatory growth as you're compensating. So basically that's rapid growth that's achieved by optimal nutrition that's provided after a period of slowed growth and malnutrition. So for example, if you have an animal that for some reason didn't get its required nutrients at some point, and it really had slow growth and it had kind of lost weight, if you then provide that animal with optimum nutrition, it will compensate for that loss in body weight, and it will actually have rapid growth to kind of catch up to the other animals. Sometimes, depending on the severity of how malnourished they were, they will catch up. But sometimes those animals are always going to be behind, and they're never going to fully catch up to the other ones. So it just kind of depends on how severe the situation is. So that can happen, but I will say, obviously, if you have like a runt or an animal that was really small to start with, compensatory growth that's not really the case there. They're going to kind of always be smaller and always behind. So this is really growth that just follows, an animal that was the same size as everybody else and then kind of was malnourished. Does that make sense?
Yeah.
So genetics, which we've already talked about, so you can kind of see how all of this plays into it. So genetics can play a part in growth and development. So you want to select animals with superior growth rates. And so we talked about heritable traits, if you want to see how heritable their traits are and how well they're going to grow. So you can keep data on all of your bulls if you have them, or probably you probably wouldn't have multiple unless you have a huge operation. But keep data so you know which animals have superior growth, how fast they grew, and how much they weighed when you wanted to get rid of them, send them to market. Quantitative genetics has accelerated progress in this area because it can give a lot of information about the genetics of an animal. And then AI, or artificial insemination, allows for the selection of superior animals to be used for breeding. And so we've talked about that multiple times. So AI really gives you the option to, you can kind of get, a whole sheet of all the traits and how heritable it might be for that particular animal. And then you can make your breeding decisions based on what your goals are. And typically you're going to go for good growth quality. So stress can really impact growth. So we've talked a little bit about handling stress with cattle before. But obviously when animals are stressed, they're probably not going to be growing as well, right? Because they've got a lot going on. So when they're stressed, the adrenal cortex, which is just a part of the brain, will produce a stress hormone. And so this is in response to a stress that would be over like hours or days rather than a sudden stress. So it would kind of have to be like a prolonged stress. So like something in a field startling a cow for a second isn't going to really trigger this release of the stress hormone. It's kind of more of a lengthy stress response. So some things that can elicit this production of the stress hormone: crowding, transportation, starvation, so it could be a nutritional stress. So lots of different things there. So the adrenal stress hormone is a steroid that is actually synthesized from cholesterol. So there are two cortical stress hormones. And so these two are very, very similar. They just have kind of slightly different names and forms depending on the species that you're talking about. So cortisol is the main one that I would really like you to be familiar with. That's the one that I kind of come across and hear about the most, probably because I work with pigs. And as you can see, that's the stress hormone in people, cattle, pigs, and horses and sheep. And then in poultry and rodents, their stress hormone is called corticosterone. So just two stress hormones that do the same thing. They're very similar, just different names kind of pretty much for what species you're talking about. Might slightly differ a little bit. So these hormones will act in an animal's body to reduce growth, and they will reduce the growth of the skeleton and then break down muscle proteins. And so that is because when the animal, or even when we are stressed, you have a lot going on in the body. And so the body doesn't have a lot of energy to contribute to growth because it's dealing with that stress. So you don't want that to happen because then you're pulling energy away from growth. So good management practices will limit stressors, limit things that will stress the animal out. Obviously, if you have to transport them or you have to work them through a chute, you can't really avoid that. But just do your best to make all of that a stress-free environment as much as you can. So disease is also associated with reduced growth because if an animal is battling a disease, all the energy in its body is going to be going to the immune system. And so when that energy is being used for the immune response, it's not being used for growth. So also important to manage disease when you can. So there can be different abnormalities in growth. A lot of different things can happen, so I'm just going to touch on a couple of them. Dwarfism is one, and that's basically just failure to grow at the appropriate rate to achieve the normal mature weight. And so you can see on the right this picture. Apparently this is something that can be, I don't know about how common it is, but it can happen in dogs. You have this mature German Shepherd, and then on the right, it kind of looks like a puppy, but that's actually a dwarf German Shepherd. So you can kind of tell that it didn't really grow properly. If you look at its coat, it just doesn't really look like that healthy of an animal. And so that's caused by a couple different things that could have caused that. But so that's dwarfism basically, and it can happen in other species. So there are several causes of dwarfism. So the one that's often seen in dogs would be a deficiency in growth hormone itself. And then another thing that could lead to dwarfism would be an IGF-1, so insulin growth factor 1 deficiency. Because remember, growth hormone is able to stimulate growth by stimulating the production of IGF-1. So a deficiency in either of those hormones would impact growth. So it just depends on where the deficiency is. So in an IGF-1 deficiency, the animal will actually have normal levels of growth hormone. But if that growth hormone is not causing normal levels of IGF-1, you're still going to have problems with growth. So this is often seen in people, miniature cattle, and dwarf chickens.
Dwarf chicken. Oh, that's right.
Yeah, which I really need to look up a picture of because that kind of sounds adorable.
Could it be like a Banny? Or is Banny still just a different breed of chicken, right?
I'm not sure. I'm not super up on every species of poultry, so I really can't. I don't want to tell you wrong. I'm not sure. There are some breeds though, like within different species that are kind of like they've been bred to be smaller. Like there are cats. I don't remember if the name is actually like dwarf cat, but there are cats. There's a breed of cats that's been bred to be like tiny, and they have the shortest little legs ever. And so it's actually a breed now instead of one or two cats that just had a deficiency in one of those hormones. So it could be like that with whatever chicken breed that you're thinking.
Yeah, Banny. It's like you can hold it in one hand.
Oh, wow, that's cool.
We had some.
Cool. So another abnormality that can happen with growth is hypothyroidism, and that means that there are low levels of thyroid hormones, and this can impact growth because thyroid hormones are essential for growth and development. And so the way that I always remember, so there's hypothyroidism or hyperthyroidism. So hypo is low. Low, they kind of sound similar. It's how I keep it straight. And then hyper, I think like hyper, like you're really active. So hyper means more, so higher level. I don't know if that helps you. Just thought I'd share. So hypo means low levels of thyroid hormones. This can be seen in horses. Foals can show, there's supposed to be a space there, musculoskeletal deformities. So that can really impact growth. And this could be something that's caused by toxins from the plants that a horse may have eaten that affect the thyroid gland. So it's really important, like we talked about in that lecture, all of those different plants that produce toxins, it's really important to make sure that you keep those out of your pasture. So another abnormality that I kind of mentioned earlier is runting in pigs. So this is where you have a baby pig that has impaired growth. And they will show lower rates of growth through weaning and post-weaning. So this is a situation where they're probably not going to ever show that compensatory growth because they were runts from the beginning. They started out at a lower point than the other animals, so the chances that they're going to catch up are slim to none. So this is something that's thought to be due to the uterine environment during gestation that could restrict intrauterine growth. And so it could be something like, sows typically have litters of anywhere from like 7 to 12, depending on the breed. And so if you have a bunch of pigs, there's only so much room, and you might have one pig that kind of gets a little crowded and doesn't really get as many nutrients and doesn't really have that space to grow. And so that can happen. So it can actually restrict their postnatal growth once they're born, because like I said, they're starting off at a worse starting point than the other pigs are, and so they most likely won't catch up. They'll always be kind of small and behind. So aging is another important thing to talk about with growth and development. However, aging is not really a huge issue with livestock animals, because typically animals are either sent to market or culled well before they're considered in their old age. So really, I think the only time that this could, well, not really the necessarily only time, but one time where this might kind of be important with livestock animals is, I know in dairy cattle, a lot of times you'll have like a really, really good high producing dairy cow that you might want to keep around. And so aging might come into play there, and you might need to start kind of thinking about what you're going to do in that situation. But typically livestock animals that won't really be a concern. However, it is a concern in companion animals, and anybody that's had dogs or cats or horses can probably attest to this. So companion animals can show aging signs just like people do. So they can have mental deterioration, reduced muscle, they can get diabetes, cardiovascular disease, cancer, all kinds of problems. And animals age more quickly than humans. Obviously, if you've ever had a dog or a cat, you know this to be true. So that's something that's becoming more of a concern in companion animals. Also, aged or geriatric horses, you have a greater incidence of colic, dental disease, tumors, lameness, and pituitary disease. So lots of different things that can happen when those animals start to age, just like in people. So just things to be aware of if you have an animal that's getting up there. You want to just kind of do what you can to assuage some of these symptoms. So there are growth stimulators and promotants that have been used in cattle. So hormonal implants have been used extensively in cattle to improve growth rate and feed efficiency. So these would contain hormones such as estrogen, androgens, which would be like your testosterone, or progesterone. Implants have FDA approval in the US, Canada, and other countries, but they're prohibited in the European Union. And so typically things that kind of start in Europe kind of end up trickling over to the US. So it's possible that things will get more restrictive in the future on those. So some practical uses of growth promotants, there are several advantages. So a use of these implants will give you an improvement of around 15 to 20% in growth rate and improve feed efficiency, which would lower your feed cost. And so another advantage is that these can work for either small or large scale production. It doesn't really matter the size of your system. A disadvantage, however, is that there have been some decreases in carcass quality that have been observed. So that's something that needs to be kept in mind too, depending on what your end goal is. So just to kind of go through a little bit more about the growth promoters, so just a little terminology. An agonist is just a chemical that mimics a natural hormone or neurotransmitter. So it's something that looks exactly like, testosterone. So you could use an agonist, and that will bind to the receptor for that hormone and actually create a biological response the same way that that hormone would. So that's an option for growth promoters. You also have adrenergic growth promoters, which is basically just a compound like epinephrine or adrenaline. So those are just kind of two different categories there. So you have, So adrenergic agonists such as growth stimulators and promotants. Ractopamine is one that's pretty common, and that was commercialized by Elanco, and that improves the performance of pigs and cattle. However, sometimes depending on where you're selling the animals to, they may not take animals that have been had that used. So I know there are a couple of pig markets in North Carolina that will not take pigs that have had ractopamine. So it's important to know what your end goals are, where you're going to be selling those animals, and what their guidelines are for what you fed them. So ractopamine acts by increasing the deposition of muscle protein and reduces the amount of triglyceride or fat. So this is really important because the muscle is the meat. That's what people are going to eat. So the more muscle you have, the larger or the more carcass you're going to have. So more meat you have to sell. And it increases the breakdown of triglycerides. So the breakdown of those fatty acids in adipose tissue. And it reduces the synthesis of fatty acids and triglycerides. So that's how it really kind of contributes to more muscle, because it's really impacting what's going on with the deposition of fat. So antibiotics have also been used as growth stimulators or promotants. So they've been used in poultry and pig industries as antimicrobial growth promoters, or AGPs, for 50 years or more. However, the European Union banned AGPs based on the view that they're responsible for the development of antibiotic resistance. So I'm sure that a lot of you have heard about antibiotic-free meat and all the hype about that, and all of these things, even though I will say antibiotics were never in your meat because they all have a withdrawal period before the animal goes to slaughter. But your typical consumer doesn't know this. So consumers kind of got really, really concerned about it. And then also with overuse of antibiotics, bacteria will start to develop antibiotic resistance. And that's going to be a big problem, because if you have a bunch of bacteria that suddenly you don't have any antibiotics that can get rid of it, you're going to have a big problem. So antibiotic resistance was a major concern. So as of January 1 of this year, the Veterinary Feed Directive actually came out, and that has impacted antibiotic use in the U.S. So just to give you a little information about this, just so you're aware, so if you ever run into anyone in the grocery store that's like, oh, I have to have antibiotic-free meat, it is. So the Veterinary Feed Directive basically was decided on kind of by the FDA. The FDA put out this rule. So the FDA is moving to eliminate the use of what they call medically important antibiotics. So those are antibiotics that are also used in human medicine, because if you're using them a lot in animals, the bacteria are exposed to these antibiotics a lot more, and bacteria can very quickly alter their genome and become resistant. And so if you have antibiotics that are going to be used to treat diseases in people or infections in people, you don't want a lot of resistant strains out there. So they've started with removing the use of medically important antibiotics for production purposes. So, for example, they can't be used for growth promotion and feed efficiency anymore. And then they want to bring their remaining therapeutic uses. So, for example, if an animal is sick and it does need an antibiotic, that is now under the supervision of a licensed veterinarian. So in order to give that antibiotic to the animal, you would have to have a vet actually sign off on it and write that prescription. So the Veterinary Feed Directive final rule is an important part of the FDA's strategy to ensure that these medically important antibiotics are being used judiciously in food-producing animals. So that's their overall goal. And this is really important because the way that this rule is set up, more antibiotics can be added pretty much at any point in time. So some of them are already on the list that fall under this category that producers can no longer use, and more can be added in the future as things kind of progress. So it's really, really important to be aware of this. And that's why my research is actually on the use of probiotics to kind of replace antibiotics because of this new rule that came out this year. Because obviously when you take antibiotics out of the feed, you're not getting that growth promotion and feed efficiency, and the animals may not be quite as healthy. So we've got to figure out what we can do and feed them to replace that. So if anybody's really, really interested and you really want to read up on this, I put the link there for you, and that'll take you to the FDA website, to the page about the VFD, if you're really curious. Any questions on that? Okay. So with that, we will move to the last lecture in this section, which is also super short. Any questions on growth or anything before I get started with this lecture? All good? Okay. So now I'm just going to briefly introduce a little bit about lactation. I'm not going to go too heavy into lactation. I didn't really cover that much of lactation when I took intro. So typically when you'll learn a lot more about lactation is kind of if you go into more of a dairy specific focus. But so since this is intro, I will kind of introduce it to you a little bit, but we're not going to go really far into the details. So lactation is extremely important. It's a common feature in mammals, and that they produce milk by the mammary glands, and that happens in the mature female. And the reason that they do this is obviously to provide nutrition for the newborn, because that's how they feed their babies in the wild. So this provides a tremendous advantage to the young mammal because they don't have to like be born and then go forage for food. They have their mom's milk for at least a good period of time until they're old enough to start getting food on their own. So just a couple of quick definitions before we jump right into this. So the alveolus is just the site of milk production. Colostrum, which should look familiar to you, which we talked about earlier, that's the first milk. And it's high in maternal antibodies, so it gives the neonate or the baby passive immunity. So that's really, really critical. It's very important. Lactogenesis is just the initiation of milk production. So remember, we talked about how pretty much anything that ends with genesis, that word means that it's kind of a process that's producing something, the start of something. And so lactose is the milk sugar. So it's a combination of glucose and galactose. So that actually makes it a disaccharide. So just to kind of put that lecture in perspective. So lactogenesis is the initiation of milk production. So think lactose and then genesis, producing something. So mammogenesis is the development of the mammary gland. So that word also kind of tells you what it is almost. So I keep clicking. Okay, so the first milk that's produced, like I said, is colostrum, and it contains antibodies, so it's really important. And especially like if you have cattle, I know sometimes like my uncle on his cattle farm, is if you have a cow that's not letting its calf nurse, you want to make sure that you collect that colostrum. It might be a challenge, but make sure that you get that so that the calf, even if it's being bottle fed, gets that first milk. And even if there's any, like if you have a cow whose calf dies, it's good practice to go ahead and collect that colostrum anyway from her and just keep it, freeze it, and store it, because you never know when you may have another calf that's going to need that. So that's just a good practice if you have livestock animals. The milk contains a mixture of different proteins. So the major protein in milk is casein. So kind of be familiar with that. That's one that I'd really like you to know. Obviously, it's in bold because that is the major protein that's found in milk. So lactose is the major sugar that's found in milk. So make sure that you keep those straight. And so if you kind of think about the way it sounds, casein kind of sounds like other proteins, like other amino acids, like lysine. They all kind of end in that "ine" sound. So milk also contains lipids and fats. It contains minerals in solution or minerals that are bound to proteins. And so phosphorus may be bound, and then it also contains water. So lots of different things. So a little bit about the anatomy of the mammary gland. So mammary glands vary in the number and position in different mammals. Obviously, so it depends on the species that you're looking at. So humans have 2, goats and sheep also have 2. You have 4 in cattle, dogs have a lot, and then you can have as many as 12 to 16 in pigs because pigs will have very large litter sizes. So they're always located on the ventral or front surface, so that just means kind of like the underside of the animal. So they are composed of the mammary gland, and then that also means that it also has the nipple or teat there as well. So that's kind of like the whole anatomy of that. So the mammary gland consists of a series of branching ducts that will lead from the teat to the milk-producing alveoli. So basically, that's just the plural word for alveolus. So tissue types in a mammary gland, you have the alveoli, the ducts, connective tissue, and then you have adipose tissue. So milk will come out of the mammary gland and pass through the teat. which can prevent pathogens invading the ducts of the mammary gland because it would have to go through the teat first. And so remember we talked about mastitis, which we'll hit on again in a little bit. So it has to come all the way out of that gland and through the teat before it can get to the animal. So there are 3 different stages in the development of the mammary gland, or mammogenesis. So prior to puberty, the mammary gland in a female will consist of just a simple duct system in the tissue that will lead to the teat with mammary adipose tissue. So kind of just a simple setup prior to puberty. So then once puberty happens, the duct system will actually begin to further develop, and that's due to the influence of estrogens. So the major female hormone, estrogens, are going to impact the female reproductive tract as well as the mammary gland. So that kind of makes sense. So when puberty happens, estrogens will cause this duct system to become very branched, and you'll have more lobular alveolar development that's, again, caused by estrogen and progesterone. So can anybody remember what progesterone does, what that hormone's important for?
I know it has to do with pregnancy.
Mm-hmm. So does it end it or does it keep it?
I think it keeps it, doesn't it?
Right. Progesterone maintains pregnancy.
Right.
So progesterone is produced by that corpus luteum that's formed once a follicle's been released. And progesterone is going to maintain that pregnancy. And so obviously you don't have milk production unless you have a sustained pregnancy. So it's also impacted by estrogen and progesterone. So if you kind of think about what those hormones do, it makes sense that that would kind of play a role in milk production. Because obviously if you don't really have progesterone, that means you're not maintaining a pregnancy. You don't really need to be producing a lot of milk. So when pregnancy happens, that's when the mammary gland completes its development. So the duct system will become even more branched, and at the end of each duct, you'll have an alveolus, which is where the milk is produced, and then you'll have further growth of the parenchymal and adipose tissues, but you don't really need to worry about exactly what those are. So milk production and how it's maintained is critical to the survival of a newborn animal and for rapid growth, obviously, because you want the animal to be getting all the nutrients that it needs as a baby to grow. So alveolar or exocrine cells play a major role in the synthesis of lactose, which is the major milk sugar, casein, which is the major milk protein, as well as other proteins and triglycerides or other lipids. So milk production has to meet the changing needs of the growing offspring. So milk production has to increase as the offspring get bigger, and they will require more energy and more protein and more nutrients. So milk production has to be able to keep up with the growing offspring, because obviously a newborn animal is not going to drink as much, and it's not going to require as many nutrients at that level that a growing animal will for as long as they actually stay on their mom. So it's really important that milk production is keeping up with those needs. So the control of milk production by hormones can be different in different animals. So in rats and humans, prolactin is a major hormone. And so suckling will actually cause an increase in prolactin secretion. And so that will just, that's just one of the ways that it's controlled. In ruminants like cattle, the major hormone that stimulates milk production is actually growth hormone. So there are big differences in species. So there are 2 mechanisms by which milk leaves the mammary gland. So there's the opening of the street canal so that milk in the teat cistern in the udder can exit passively. So passively means that it's kind of just exiting. It's not requiring any energy to do that. There's the milk letdown response, where milk is forcibly ejected from the mammary gland by contractions of myoepithelial cells that surround the alveoli. So there are just cells around that gland that will cause it to contract and eject the milk. And so the milk letdown response is a neuron endocrine reflex. So if you remember neuron, does anybody remember what system neurons are cells that they're part of?
The nervous system.
The nervous system, exactly. So remember, the nervous system is responsible for control and communication of different body parts and different body processes. So This milk letdown response is a neuroendocrine reflex, so it's controlled by the nervous system. So there are ways to improve milk production. So obviously there are ways to improve pretty much any aspect of production. Management and nutrition are essential for high milk production. So obviously dairy producers know a lot about this. You want to avoid stresses like we talked about, because when you have stress, you're pulling energy away from other things in the body. And if you want milk production, you don't want to be pulling energy away from milk production. So avoid stresses such as extreme heat or cold temperatures. Another management approach could be to terminate lactation, or what's called drying the animal off between lactations. So the mammary gland will undergo kind of involution. Genetics, you can actually improve pretty much almost anything through genetics. So genetic selection for milk production. If you have a dairy system, you want to select cows to breed that have had good milk production in the past, or you want to use bulls that have sired animals that have had good milk production. So you want to look at the genetics there. Artificial insemination, to use semen from bulls with proven ability to sire superior heifer calves can result in improvement in milk production. So just really utilizing artificial insemination if you can, if that's something that you want to do and that makes sense for your operation, can really help, because you will have a lot of information about that bull and its traits, and that semen's been checked for quality. So bovine somatotropin, and so remember somatotropin is another term for growth hormone. So remember that in cattle, milk production is kind of influenced by growth hormone. So another approach to improve milk production is to use bovine somatotropin. So it's widely used by dairy farmers to increase milk production and its efficiency. So it would result in more milk per cow, more milk per unit of feed, more milk per unit or per facility, and less animal waste per unit of milk produced. So that's also less animal waste would be kind of an environmental factor there that farms also have to kind of think about. So oxytocin is also a synthetic hormone that can be used in cattle to cause milk letdown. So different ways there that you can inject hormones, and you can kind of manipulate this in an animal if you have the time and money and want to do that. So there can be problems with lactation. We've mentioned before, we talked about mastitis when we did the dairy cattle lecture. So if you remember, that's an inflammation of one or more quarters of the mammary gland. So in a cow, you have four, obviously quarters, because quarters means four. And so one could be affected, or you could have two. All of them could be affected. Obviously, the severity will depend on how far it's progressed. But so even if it's only one, that's still a significant situation, and you still have mastitis. So this is the most significant disease that happens in dairy cattle. So it can be a huge problem if management practices don't take care of it. So that will cause losses due to reduced milk production, unsaleable milk. So even if they are producing milk and it's coming out of an infected udder, you obviously can't sell that, and no one is going to drink it. And long-term damage to a mammary gland. And then that can eventually lead to you having to cull that animal. So if you have a dairy operation or any dairy producer, mastitis is extremely important to keep under control. So I know sometimes people they'll dip the teats in like an iodine solution or maybe some other solution to kind of prevent and kill off bacteria that may be around that area, so that they don't get into the udder and actually affect the mammary glands. So mastitis is really, really important. Any questions on lactation? I know that was kind of brief, but I don't feel like for intro you have to get super into lactation. So any questions on that?
Why do cows have hooves?
Is this one of your jokes?
Yes.
I don't know.
Because they lactose.
Good one.
Toes.
Actually, cows have two toes.
They have hooves.
They're two-toed ungulates.
They have hooves. They don't have toes. They
Yeah.
have toes. They lack toes.
That's funny.
Ha, ha.
Well, if nobody has any questions,
Don't be
then I'll
lactose intolerant.
make sure that you look on Blackboard and see that assignment, because this material is hard, and I'm going to try not to be detailed on the test, but the material is really challenging. So make sure that you're studying in advance and really go through those questions. And if you don't understand something, email me, and I'll try to explain it better for you. But if nobody has any other questions, then I'll see you on Thursday for the review. Come with questions if you have any.
Awesome. See you Thursday. Have a good day.
You too.
Bye. Bye.